In this video, we will practice using sine and cosine to find the coordinates of a point on any circle. This is AP Precalculus topic 3.3. If you appreciate this content, please give it a like. Given an angle theta in standard position passing through the point x, y on a circle with radius r, we have memorized that the sine of theta is equal to y over r, and the cosine of theta is equal to x over r. But let's rewrite this. If you were to multiply both sides of this equation by r, the r's would cancel each other out, and the equation would become r sine theta is equal to y. Similarly, if you multiply both sides of the cosine equation by r, the r's cancel out, and this equation becomes r cosine theta is equal to x. Flipping this around, if I need to find the y-coordinate of any point on a circle, y will always equal r sine theta. Memorize this. If I need to find the x-coordinate of any point on a circle, it will always be r cosine theta. Putting it all together, the coordinates of any point x, y on a circle will be given by r cosine theta, r sine theta. Many problems in trigonometry revolve around equilateral triangles. That's a triangle with three equal sides. If all three sides are equal, then all three angles are also equal. Back in geometry, you learned that all the angles in a triangle add up to 180 degrees. If you take 180 degrees and you divide by 3, you get 60. So, each angle in an equilateral triangle is 60 degrees. However, in precalculus, we don't deal with degrees. We use radians. 60 degrees is equivalent to pi over 3 radians. So in an equilateral triangle, each angle is pi over 3. If you take one of those pi over 3 angles and split it down the middle, each half is pi over 6. Number 1. The figure above shows a circle of radius 3 along with the equilateral triangle PQO. Which of the following gives the coordinates of point Q? If we draw angle theta in standard position with terminal ray passing through point Q, then the coordinates of Q will be r cosine theta, r sine theta. We know that r is 3. They gave us the radius. We just need to figure out what theta is, and then we can write the coordinates. Because they told us the triangle is an equilateral triangle, we know that every angle is pi over 3, including this red angle right here. We also know that a semicircle is pi radians. That means this red angle in the middle is pi over 3. That's literally a third of pi. So if this middle angle is 1/3, that means that each of the other two angles must be the other 2/3. So this angle over here is also pi over 3, and this angle over here is also pi over 3. Together they make 3 pi over 3. That's pi. Now we can easily figure out the measure of angle theta. Pi is right here, but let's think of it as 3 pi over 3. So we are going one extra pi over 3 past 3 pi over 3. That means theta must be 4 pi over 3. So the coordinates of point Q will be r cosine theta, r sine theta. So that's going to be 3 cosine 4 pi over 3, 3 sine 4 pi over 3. That's why the answer is B. Many problems in trigonometry involve isosceles right triangles. An isosceles triangle is a triangle that has two equal sides. So, an isosceles right triangle has two equal sides and a 90-degree angle. Here's a square. In geometry, we would have said that each one of these angles is 90 degrees. In radians, we will say that these are each pi over 2. If you split one of these angles down the middle, half of pi over 2 is pi over 4. Half of a square is an isosceles right triangle. So anytime you are given an isosceles right triangle, know that one angle is pi over 2, and the other two angles are pi over 4. Number 2. The figure above shows a circle of radius 9, along with the isosceles right triangle PQO. Which of the following gives the coordinates of point Q? Once again, we just need to figure out the measure of angle theta in standard position, with terminal ray passing through point Q. Because this is a right triangle, we know that this angle right here is pi over 2, but this angle is being split right down the middle. So each half of this angle is pi over 4. Now we can easily determine the measure of angle theta. We know that pi is right here, but let's think of it as 4 pi over 4. So the terminal side of theta is one multiple of pi over 4 past 4 pi over 4. So theta must be 5 pi over 4. A point on a circle is given by r cosine theta, comma, r sine theta. So the coordinates of point Q should be 9 cosine 5 pi over 4, comma, 9 sine 5 pi over 4. That's why the answer is D. Number 3. The figure above shows a circle of radius 5 along with the equilateral triangle PQO. Which of the following gives the coordinates of point Q? We need to find the measure of angle theta in standard position that starts on the positive x-axis and then rotates around and ends at Q. We know that all three angles of an equilateral triangle are pi over 3 radians. But this angle is being split in half, so each side will be pi over 6. Specifically, this angle right here is pi over 6. The angle between the terminal side and the nearest part of the x-axis is called the reference angle. With this reference angle of pi over 6 in mind, let's think of pi as 6 pi over 6, and let's think of 2 pi as 12 pi over 6. Now we can see that angle theta is one multiple of pi over 6 short of 12 pi over 6. Therefore, theta is 11 pi over 6. The coordinates of point Q will be given by r cosine theta, comma, r sine theta. Since the radius is 5, we have 5 cosine 11 pi over 6, comma, 5 sine 11 pi over 6. So the answer is C. Number 4. The figure above shows a circle of radius 15 along with the isosceles right triangle PQO. Which of the following gives the coordinates of point Q? This is a right triangle, so this angle right here is pi over 2, but it is being split down the middle, so each half will be pi over 4. But also each quadrant is pi over 2. So if this angle is pi over 4, this angle must also be pi over 4. Now we can find the measure of angle theta that ends at point Q. Pi is right here, but we will think of it as 4 pi over 4. 2 pi is right here. Let's think of that as 8 pi over 4. So the angle theta is pi over 4 less than 8 pi over 4. So it must be 7 pi over 4. But now we run into a problem. The coordinates of point Q are given by 15 cosine 7 pi over 4, comma 15 sine 7 pi over 4. But that doesn't match any of the answer choices. This is correct, but the answer must be written in an equivalent form. The angle between the terminal side and the nearer part of the x-axis is called the reference angle. In this case, the reference angle is this pi over 4. There is a way of writing the coordinates of a point using the reference angle instead of theta. In standard position, pi over 4 is in the first quadrant. So the coordinates of this point will be r cosine theta, comma r sine theta. That's going to be 15 cosine pi over 4, comma 15 sine pi over 4. We can use symmetry to translate these coordinates into the coordinates of point Q. Because point Q and this orange point are equally far to the right, they will both have the same x value. So point Q will have an x coordinate of 15 cosine pi over 4. However, these 2 points will have opposite y values. One is positive and the other is negative. So the y coordinate of Q will be negative 15 sine pi over 4. That's why the answer is C. Find the exact values of the following expressions. Number 5, the sine of 3 pi over 2. Every quadrant is a multiple of pi over 2. So right here at the top, this is 1 pi over 2. Over here on the left, this is 2 pi over 2. And down here at the bottom is 3 pi over 2. Because the terminal side is landing right on the y-axis, we use coordinates instead of memorized values. And this is a little unit circle. So the radius is 1. So the coordinates will be 0, comma, negative 1. 0 because we are right on the y-axis, and negative 1 because we are 1 unit down. Remember that on the unit circle, cosine x is the x value, and sine x is the y value. So in this case, we want sine, so that's the y value, which is negative 1. Number 6, cosine of 2 pi. 2 pi is right here. The coordinates are 1, comma 0. Again, this is the unit circle, the radius is 1, so this is over 1, up 0. Cosine is the x value on the unit circle, and the x value is 1. So the cosine of 2 pi is 1. Number 7, every quadrant is a multiple of pi over 2. So 1 pi over 2, or simply pi over 2, is right here at the top. This is pi over 2. Since this is on the line, we will use coordinates. And this is the point 0, comma 1. On the unit circle, the cosine is the x value. So the cosine of pi over 2 is 0. Number 8. We know that pi is right here. The coordinates at this point are negative 1, comma 0. On the unit circle, sine is the y value, and the y value is 0. So the sine of pi is 0. Number 9. 0 is right here. The coordinates are 1, comma 0. Cosine is the x value on the unit circle, and the x value is 1. So the cosine of 0 is 1. Pi over 2 is right here. The coordinates in this spot are 0, 1, and sine is the y value on the unit circle, so the sine is going to be 1. So that's the answer to number 10. For number 11, a negative angle means that we rotate in the clockwise direction instead of the usual counterclockwise direction. Pi over 2 would be up here at the top. That's where we would land if we went pi over 2 counterclockwise. But if we go pi over 2 clockwise, we end up down here at the bottom. The coordinates down here are 0, -1. On the unit circle, sine is the y value, and here the y value is -1. So the sine of negative pi over 2 is equal to -1. Odd multiples of pi always end up right here. This is 1 pi, 3 pi, 5 pi, 7 pi, 9 pi, and so on. The reason is because when we go 1 pi, we end up here on the left, and then if we keep going another pi, 2 pi, we're here on the right. Then 3 pi brings us back to here, 4 pi brings us here, 5 pi brings us here. So every time we say an odd number, we're on the left, and every time we say an even number like 2 pi, 4 pi, 6 pi, we are on the right. So you should be able to do problems like this even if you are given a really big number, like if I say the cosine of 313 pi. You should know, oh, that's going to land right here. Anyway, the coordinates in this position are -1, 0. On the unit circle, cosine is the x coordinate. So the cosine of 3 pi is -1. How do we evaluate sine and cosine when the terminal side does not fall right on the x-axis or the y-axis? I want you to memorize all of the values on this chart. Practice writing this on a piece of scratch paper from memory, and the next time you have a test or a quiz, ask your teacher for a piece of scratch paper and write down the chart. Then you can use the chart to do the test or the quiz. Eventually, I want you to know this so well that you don't even have to write it down. But, you know, baby steps. Number 13. The sine of 3 pi over 4 will be the same as the sine of pi over 4, which is radical 2 over 2, or you could write 1 over radical 2, which means the same thing. Except this might be negative, depending on the quadrant. We know that pi is right here. With a denominator of 4, let's think of this as 4 pi over 4. Therefore, 3 pi over 4 is going to be one multiple less, which puts it in the second quadrant. On the unit circle, sine is the y value, and y values are positive in the second quadrant. We are above the x-axis. So we will leave the answer as positive radical 2 over 2. Number 14, cosine pi over 3 is right on the chart. That's 1/2. Number 15, the cosine of 7 pi over 6 will be the same as the cosine of pi over 6, which is radical 3 over 2, except it might be negative depending on the quadrant. With this denominator of 6, let's think of pi as being 6 pi over 6. Therefore, 7 pi over 6 will be one multiple past that, which puts it in the third quadrant. On the unit circle, cosine is the x value, and x values are negative in the third quadrant. We are to the left of the y-axis. Therefore, the cosine of 7 pi over 6 will be negative radical 3 over 2. Number 16, the sine of 2 pi over 3 will be the same as the sine of pi over 3, which is radical 3 over 2. Except it might be negative depending on the quadrant. With a denominator of 3, let's think of pi as 3 pi over 3. Therefore, 2 pi over 3 will be one multiple before this, which puts it in the second quadrant. On the unit circle, sine is the y value, and y values are positive in the second quadrant. We are above the x-axis. So we will leave the answer as positive radical 3 over 2. For number 17, the sine of pi over 6 is right here on the chart. It is 1/2. Number 18, the cosine of 5 pi over 4 will be the same as the cosine of pi over 4, which is radical 2 over 2, or you can write 1 over radical 2. I'm going to switch it up and write 1 over radical 2 this time. Except it might be negative depending on the quadrant. With a denominator of 4, let's think of pi as 4 pi over 4. Therefore, 5 pi over 4 will be one multiple past this, placing it in the third quadrant. On the unit circle, cosine is the x value, and x values are negative in the third quadrant. Therefore, the answer will be negative 1 over radical 2. Number 19, 2 pi lands right here on the unit circle. When the terminal side is right on the line, we use coordinates instead of this chart. So this is the unit circle, so the radius is 1. The coordinates of this point will be 1, 0. It's over 1 and up nothing. Cosine is the x value on the unit circle, so the cosine of 2 pi is 1. For number 20, we are still at 2 pi, but sine is the y value, so the sine of 2 pi will be 0. The cosine of 5 pi over 6 will be the same as the cosine of pi over 6, which is radical 3 over 2. Except it might be negative depending on the quadrant. We can think of pi as 6 pi over 6. Therefore, 5 pi over 6 will be one multiple before 6 pi over 6. So it's in the second quadrant. Cosine is the x value on the unit circle, and x values are negative in the second quadrant. So the answer will be negative radical 3 over 2. Number 22. The cosine of 11 pi over 6 will be the same as the cosine of pi over 6, which is radical 3 over 2. Except it might be negative depending on the quadrant. We can think of pi as 6 pi over 6, and we can think of 2 pi as double that, 12 pi over 6. So 11 pi over 6 is one multiple before 12 pi over 6. That's in the fourth quadrant. On the unit circle, cosine is the x value, and x values are positive in the fourth quadrant. We are to the right of the y-axis. Therefore, we will leave the answer as positive radical 3 over 2. Number 23, the sine of 7 pi over 4 is the same as the sine of pi over 4, which is radical 2 over 2. Except it might be negative depending on the quadrant. We can think of pi as 4 pi over 4, and we can think of 2 pi as 8 pi over 4. So 7 pi over 4 will be one multiple before 8 pi over 4. Therefore, it is in the fourth quadrant where y values are negative. So the answer will be negative radical 2 over 2. Number 24, the sine of 7 pi over 6 will be the same as the sine of pi over 6, which is 1/2. Except it might be negative depending on the quadrant. And we can think of pi as 6 pi over 6, which means that 7 pi over 6 will be one multiple past that, placing it into the third quadrant. Sine is the y value on the unit circle, and y values are negative in the third quadrant. So the sine of 7 pi over 6 is equal to negative 1/2. That's the end of the video, but I want you to do one more thing. Go get a piece of scratch paper and see if you can create this chart from memory. Then look back at the screen and see how you did. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.